Alright guys, so we're starting vectors. It's a big unit. You can see we've got a big checklist out front there. And we've done two-dimensional vectors in year 11, and so the only extension on here is that we just add an extra number at the end. So today, I think my plan would be to go through 5A, 5B and 5C, and I think we'll just go through the notes up here all together for all of them, and then you can just get into the exercise and practice those skills. We'll be pretty familiar with them. Just turning the page, I'll just point out the first two pages we've got here. I've cut this out of the curriculum statement. So this is what we're expected to teach you as teachers. And so if you want to have a look at, how does SACE present it and so forth, it's all there. Happy to answer any questions about it. But we're going to cover all of this content in the next 6-7 weeks. All right, so we'll begin with vectors in space. And, what is a vector? It's a direction and magnitude. Yep. A quantity with direction and magnitude. So we have a position vector describing the vector from the origin to a coordinate, OP. And we have magnitude of a vector. If the vector is x, y, z, then the magnitude of the vector is the square root of each component squared. So we've got consider P. So we'll start with 5A, vectors in space. Consider point P, which is -2, 3, and 4. All right, so we're familiar with this is the x coordinate, this is the y coordinate, and now we're adding on this the z coordinate. Okay, part A says plot this point in 3-dimensional space. Now it's quite tricky to plot 3D space. So what we'll do is we'll just have x and y that we're familiar with. And then z is sort of coming out of the page. So we'll have positive z coming out here off the whiteboard and negative z in that direction. We have negative y in this direction and negative x in this direction. And if it helps, you can make the negative ones dotted such that they And so we have point P, it's -2 on the x, so we'd be going across 2 here, up 3 on the y, and then out 4 on the z. So, there, obviously. Alright, so that's probably the best we can do to sketch it, really. Not something you'd be required to do in a test. Sketching 3-dimensional spaces on a two-dimensional plane is near impossible. Instead, we're just introducing you to the concept of it. Okay, determine the distance from the point of origin. All right, so the point of origin is here, it's point O. And so what we want to know is we want to know the magnitude of vector OP. Okay, so just in terms of notation, this arrow here means vector from O to P. All right, and we're interested in the magnitude of it. We want the distance of it. Now vector OP, all right, what that vector means is it's the coordinates of O, take the coordinates, the coordinates of P, take the coordinates of O. All right, so it's always the second coordinates, take away the first coordinates. So it's -2, 3, 4, take away 0, 0, 0, which is -2, 3, 4. It's a vector, so we use square brackets to denote this is a vector, it's not a coordinate, okay? P here, round brackets for a coordinate, OP, square brackets for a vector, and we generally don't put commas, so that's my mistake, sorry. We generally don't put commas between them, we just have a space separating them. Now you will see in the textbook as well, they do write that like this, -2, 3, and 4. So either notation that you choose to use is fine. All right, historically SACE has used horizontally. I think now they're tending to use more vertical. Doesn't matter, they mean the same thing. I'm probably going to use horizontal. All right, I'll try to be consistent and just use horizontal. Okay, so then we want the magnitude of vector OP. So that's the square root of, and we just need to take the magnitude, we don't need to take the negative. Square root of 2 squared plus 3 squared plus 4 squared. So we've got 4 plus 9 is 13 plus 16 is 29. Okay, so the distance between O and P is the square root of 29 units. Okay, so that's question 1. Then we have question 2. and we've got find k given vector AB, which equals this, k a quarter and minus a half, is a unit vector. Okay, so a unit vector is a vector with a magnitude of 1. So that means the modulus magnitude, the size, the length of this vector equals 1, which is the square root of k squared plus a quarter squared plus a half squared. So we're just solving that equation for k. We will square both sides. Subtract that from both sides to get k squared by itself. So we'll have 1, take 1 on 16 is 15 on 16. Take 4 on 16 will be 11 on 16. And then square root both sides. Plus or minus. We don't know the direction that k is pointing. It could be pointing in the positive direction or the negative direction. Both of those values will satisfy it. And if you put that in your calculator, it'll spit it out just a little bit differently. I'll apply that cert there. Very good. All right, so that's exercise 5A. Any questions about that? So finding a vector, just a second coordinate, take the first coordinate, magnitude. We've done a fair bit with complex numbers and vectors in 2 dimensions. Okay, let's move on to 5B. All right. 5B, operations with vectors. Okay, so here we have 5B. Vector A is 2, minus 3, and 1. And we have vector B is 4, 2, and minus 5. Now, find vector A plus B. All right, so vector A plus B, the vector that's going to result here, we just add the x component, the y component, and the z component. So 2 plus 4 will be 6, minus 3 plus 2 will be minus 1, and 1 take 5 will be minus 4. So this will be the resultant vector when we have vector A plus B. Okay, 2A take B. So all we're doing here is multiplying vector A by 2 first, and then subtracting vector B. So we're going to have 4, take away 4. I'll do it quickly, I think we're okay with what's going on here. 2 times 2, take away 4, 4 take 4 is 0. Minus 6 take 2 will be minus 8. And 2 take away minus 5 will be positive 7. Okay, the modulus of vector 3b. Alright, modulus of vector 3b, that means the modulus of 3 times b. So that means the modulus of this vector, 12, 6, minus 15, is going to be enormous. I've got those around the wrong way. Square bracket and then modulus. So that's going to be the square root of 12 squared plus 6 squared plus 15 squared. So 225 plus 36 plus 144. Just do that quickly. In your head, you tell me. And then we have the modulus of A times vector B. Alright, so we haven't seen this yet, but if we just do the modulus of A times vector B, we'll do the modulus of A first. That's going to be the square root of 2 squared plus 3 squared plus 1 squared. And that's multiplied by vector B, which is this one. 4, 2, minus 5. So all we're going to do is evaluate this and then distribute it to every term within vector B. So that's square root of 4 plus 9, it gives you 13, square root of 14. And we just distribute it, it's going to be 4 root 14, 2 root 14, and minus 5 root 14. Okay. All right, then on to 5C. We've got some other properties of vectors here, pretty similar to algebraic properties. Consider 4x take 2a equals 3b. Solve for vector x given a equals 2, 1, 0 and b equals 0, minus 2, 3. So this is some vector. We're just going to call it vector x. And so what we've got is vector 4 lots of x is equal to 3b take away 2a. So what I'm going to do first is just evaluate this vector and then times it by 1 over 4 to get vector x by itself. So we've got 3b is going to be vector 0, minus 6 and 9. Take away 2a is going to be 4, 2, 0. Form the mathematics. We'll have minus 4, minus 8, 9 take 0, 9. So that's what 4x is equal to. So then x is equal to a quarter, it just distributes through it, minus 1, minus 2, 9 on 4. Very good. Alright, so that's really enough of the skills to crack into 5A, B, C. Look how many questions there are in 5D. So we might get started on